Hello YouTube, today at USBCrepair.com we got a Lenovo E595 that has a USB Type-C connector issue, at least that's what the client specified. So what we're gonna do is we're gonna replace this connector USB Type-C, probably because the pins right here inside are damaged. We got a brand new connector right here, and we do have connectors for this laptop at all times, and if you need one you could buy it from us. Let me show you how we're gonna take this connector off the motherboard. You know what, let me put a different camera here. Let's add a little bit more lights. All right, let's add a little bit more lights. Alrighty. So the way how it's gonna work is we're gonna add a whole bunch of plugs right here, right here, right here, all over those pins. And then we're gonna add some solder here, here, here. On all of those pins, we're gonna add some solder. And then we're gonna add a little bit more flux again on the other side, right here. And on the back, in the rear. And then we're gonna use the hot air just to drop this connector from the motherboard. We're not gonna force the connector off the motherboard. We're gonna let the hot air do all the work because we don't want any of the traces in the back of the connection to get damaged. Because if the traces get damaged, sometimes things are not fixable, but sometimes they are fixable, but it's just gonna take a little bit more time to fix the rear. I will start working without the microscope, and then we're gonna switch to the microscope, and I will show you how to take care of the rest of the problems here. Basically, the situation is gonna be all of those pins. We got 12 pins right here. Going through the motherboard, we have to clean up every single one of those pins. On this one, we can see some oxidation here as well. I'm not sure if it's burning or is it oxidation. Looks all right. Anyways, we insulated the area with the high temperature 3M tape right here. This is the Kapton tape. Kapton tape basically is an extra layer on top of this 3M 600 degree. It can handle 600 degrees Fahrenheit, I believe. Yeah. So, and the tape also keeps the tape together here. We don't want any of the components here in the back to fly off the motherboard, and we don't want the components on the other side to fly off the motherboard because those guys are extremely tiny. If they fly off, I wouldn't even notice, and it would be pretty much impossible to solder some of the, for example, filters back into the place because they're like so microscopic. Even if we see them on the microscope, we would not be able to solder them. All right, so let's get things rolling. And again, we're gonna add some flux. And then we're gonna add some solder. All right, so I positioned the hot air on top of the connector. We're not turned on the hot air yet. What I'm doing here is I'm just using a whole bunch of flux on the motherboard. Next thing is we're gonna do is let's add a little bit more. You know what? I will preheat the motherboard just a tiny bit so that the solder will go in much easier. We're gonna use 320 degrees Celsius at about half of the air, and then we're gonna power up the hot air, and we're gonna be adding a whole bunch of solder all over the place here, so that everything would be, so that the old solder, so that the silver base solder would mix with the leaded base solder, and that way it would be much easier to desolder this guy from the motherboard. Here some flux would be appreciated, but not required. Alright, so now that we added a whole bunch of solder there, what we want to do is we just gonna put a whole bunch of flux here. Alright, and then we're gonna put a whole bunch of flux on this side. Now we're gonna bump up the hot air towards 300, I would say 50 degrees. All right. And at 350 degrees, the connector should follow the motherboard by itself. All right. Again, we've been doing this for the last few years, and we're still trying to excel this process the best we can. So any useful comments would be appreciated. Alrighty. I keep warming it up. I'm keeping it warm. And we're gonna bring the hot air closer to the connector. All right. Let's see, let's do 360 degrees. All right, at 360, it's going out just fine. All right. Alrighty. All right. You see that how it's kind of at an angle? The reason it's at an angle because the rear pins don't want to be coming out. And we don't want to break the rear pins, so we're going to put some pressure on the rear pins. Like that, and it came off the motherboard just fine. Now we want to reduce it down to 320 Celsius. Once we reduce it down to 320 Celsius, we adjust the position of the motherboard here. By the way, we are recording in 4K, so you can watch this on a big screen TV. Here we desolder the solder from every single hole there is. All right. All righty. Alrighty. Alrighty, looks good. All right, it looks excellent on this side. Let's flip it over and see what we can do on the other side. Before we're gonna do that, what we want to do is we want to add some flux. Flux will let the existing solder flow much easier. We cut the braid a little bit so it would flow better as well. And now we're just gonna do this kind of sweep. All right. All right, looks good. Okay, so we take the hot air out of equation. Let's cool it down. Now let's inspect everything under the microscope. Okay, so what do we see here? Let's try each one of those holes and see if each one is now, this one is not through. All right. This one is not through. Okay, so this one, and this one are giving us issues. All right. This is just some plastic left over. This is good. Oh, this one could be a little bit more clean. This is just flux. This is just flux. and this is just flux. So we got this one, and this one that still require a lot of attention. So the way how to get things done here is, again, we're gonna do a whole bunch of flux. All right. Then what we're gonna do is we're gonna be, are we recording? All right. So here's what we're gonna do is we're gonna add some solder. And let's find that guy that's, all right. So what we did, we filled up that hole with the solder. We filled up that hole with the solder, this one, and that one, okay? And now the goal is to suck as much solder from that hole, right? Come on. It's hard to, okay. All right, I needed to stabilize the whole thing a little bit. Now let's see if we can suck all of the solder from this hole. All right. Now let's see if we can suck everything out of this hole. Nope, we can't. All right. Now let's see if we can do same here. All right, and let's see if we can do this guy right here. Nope. All right, so we were able to clean just a few holes. The remaining holes are giving us issues. So we will need to do something different for the remaining 2 holes. Even though we got a whole bunch of flux on it and extra solder, again, unless we clean up this hole and that hole, the new jack not gonna fit into the motherboard. All right, so let's try one more time, maybe. Let's flood this guy with the solder. All right, let's flood this guy with the solder. Let's flood this guy with the solder. No, I didn't want to flood an extra hole right there. Okay. So what we're gonna do next is we're gonna take this guy and remove that, the one next to it. Now let's do the same one here. All right, so now we were able to get all of the solder from there. Let's see if we can do exactly the same thing on this guy. Nope. All right, but the most important part is those guys are all out. All right, let's do one more time. Fill up that hole. And I'm just gonna use the hot air to warm up that area. Let's set the temperature to 330. And let's clean up the soldering iron. Alrighty. Let's shut that. Oops. Did I switch? No, yeah, I was able to switch. Alrighty. Does everything look clean or nothing? Or we still got something right here? I think we still got something right there. This is clean, clean. We still got something in that one as well. All right. Here. All right, and you see why the charge to replace this connector is so high, because it doesn't take 5 seconds to do it. And by the way, this one we need to do something about as well. Yeah. Let's see what we got on the other side here. Yeah, we got this guy and we got this guy. They both are not the way how they're supposed to be. All right, so let's take the hot air out of the holder. Let's power up the hot air to, I would say, you know what, let's use some flux first. Let's put some flux here. All right. $350. All right, that's probably too big. All right. Okay, now we are able to get this thing through. Good job. Wait up. Did this thing just... No, it's all good? Yeah, looks good. Yeah, looks good. All right, so we are almost done. I mean, almost done trying to cleaning up the whole thing. So here we are able to clean this thing nicely right here, right there, and right there. All right, all good. Alrighty. Let's clean this thing up one more time. The reason I want it to be extremely clean, so that the new jack will be just sitting perfectly. You see, none of the traces got damaged. Everything looks good. So in theory, everything should work, assuming the board didn't die from constant wiggling. I really don't like how those guys are exposed right there. The small components are exposed. And I wonder if there was anything on the D2, right where the D2 is at. I need to check to see. All right, everything's fine, at least, except you see right there, something is grabbing on right here. which we're gonna desolder right now. All right. More plugs. Oh, come on. I only made it worse, I think. Oh, it's nice and clean in the middle, so it's all good. All right. Okay. All right, let's install the new connector in place. All right, let's see if the new connector gonna fit in there just fine. No, it doesn't. It's not even from this Opera. All right, so this connector is not from here. All right, let's try another connector. Nice. You see how nice it sits? Yep. Excellent. This would be excellent connector to be sitting there. All right. Like that. Let's see if it sits on the bottom as well. Yeah, all the pins are going through. All right, so the way to solder this connector in place is, first of all, we need to remove it carefully so that the pins wouldn't be, oops, wherever you put this thing, pins are gonna be pretty much everywhere. Okay, so the way to solder this guy properly is we need to retin every single one of those pads right here. Okay, in the rear, I meant to say. Okay, and you have to kind of pre-tin it carefully. Like that. You want to avoid making mistakes like the one I just did. All right, this is also a mistake. Let's see if I can just like that. Like that. And this is another mistake. Yep, so I did a few mistakes here. Let's reduce the brightness so I would know exactly what to do here. Okay. And this is another mistake right here. All right, now looks good. Looks good, looks good. Looks good. And looks good. You don't want to put too much, you don't want to put too little, you just want to put just right. And now, I don't think you can hear me, I got several exhaust fans running here at the same time. And now the goal is to put this guy, well, you know what, the goal is to put whole bunch of flux onto the rear pins. All right. All right, so I put the piece like that. All right. All right. Looks good, looks good. All right, so after a couple years of training, what we decided that we wanna cover the whole jack with the thermal tape that doesn't let the heat to go through. And now we're gonna use the, I would say 350 degrees. Probably should be even less than that. Let's do 340 degrees. All right. And what I want to do next, I want to keep the pressure down on the rear of the connection. And then what I want to do is I want to use the hot air to make sure that the rear pins will get soldered. And I'm monitoring under the Did they get soldered? Did I ruin the connector? I keep holding because I don't know if the whole soldering is done or not. So let's remove the hot air. Let's zoom in into the area. Let's adjust the focus like that. Now let's see if we can test each one. All right, so only one didn't get soldered, this one right here. All right, so let's try and see if we can correct that by going in with this super small tiny soldering iron. I'm not really happy with this soldering job, honestly. Not happy because if one didn't get soldered, it's usually not a good news. You see, this is a really good soldering right there. That means like it's gonna be extremely solid. Right there. I don't need that anymore. All right, looks good. You see, when you do it by hand, everything is much more solid. Yep, that's solid. Solid, solid, solid. Good job. All right, excellent. Now let's zoom out. Focus a little bit. Let's put some flux where we need it to. All right. Let's solder everything up here. And while we're soldering, I want to be holding down the connector downwards. Like that. Like that. Beautiful, you see? All right, let's see. Need more solder there. I don't want to overdo with the solder. All right, excellent. Excellent. You see right here it is. I want to get solder, but that's the usual situation. Let's flip the connector over. Let's flip it over. All right, here we are. Some pressure onto the connection from the bottom. Alrighty. Let's add a little pad right there. Focus everything. Let's put whole bunch of flux. All right. Let's say why so much flux? Well, it's just easier to work with. So much flux. Alrighty. 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 All right. All right, I think it looks good. Nothing got damaged in the process. Extremely solid connection everywhere. And I think the job is completed well, fine. All right. Here we're gonna do a whole bunch of cleanup. All right, guys, a like would be appreciated. subscribe. We have a whole bunch of videos on how to do USB Type-C connections. Again, there are variations of USB Type-C connections. This is the one that had the pins going through the motherboard. There's a whole bunch of other ones that don't have the pins going through the motherboard. Instead, they have pins laying down on the motherboard. All right, so we cleaned up everything good really here. And we're just gonna do clean up here as well. Yeah, well, I still need to solder those rear two pins on the top side because they are obviously not soldered. So let's finish soldering. All right, let's bring in some plugs here, some plugs there. All right, let's bring a smaller soldering iron. Let's steam the soldering iron really well. Change the position, microscope position. All right, looks good. Good. Now let's change the microscope position to the other side. And let's rotate the whole thing like that. Okay. All right. Okay, looks good. Clean up this jack a little bit more. All right. All right. And then we have to test it to make sure that every one of the pins is conducting. All right. Excellent. Beautiful. Next time I will do something different, I think. This is not gonna... I tried something new here, but I'm not really happy with the results. I mean, everything's still gonna work. When you're taking this guy off, make sure nothing is stuck to the tape here. Otherwise, yeah, all of this stuff looks like it belongs there. Okay. All right. Let's make sure the other side is also nice and clean. All right. No, I think it's an excellent job, but I think I could do much better because, again, because I tried something new here and I didn't really like the result. I mean, I was thinking it's gonna be wow, but instead I exposed the jack to too much heat from the hot air, and usually I just do the touch up with the soldering irons in the back, but here I wanted to do what other people do, which I saw online, and I don't think they do the right thing by warming up the whole connector. Yeah. Well, anyways, it does work, right? But still, those flimsy connectors. All right, looks good. Looks good. Alrighty, let's take a look if all of the pins got soldered in. Hold on 1 second. Is that as far as it goes? Like that? Okay. Let's take a look. Come on. B3 seems to have some sort of short. B2 has some sort of short. So B1 is ground, B2. Strange. Probably too much solder flew in under the connector. So yeah. There is a short here as well for some reason. Between A12 and A11. Well, let's try and power up the system and see if we get a handshake. Let's take a look. Here we get 19 volts and 1 amp right there. Well, 0.1 amp. Yep. And the fan was spinning right here. Let's try the other way around. Okay, so we get 19 volts, 0.05 amps. Should be bumped up a little bit further more, up to like 1 amp. And I was hoping the fan gonna spin. But no, it doesn't. Strange. Well, we do get the handshake and we get 19 volts. Right there, 19.4 volts going through. And here we get again 19.49 amps, volts, and 0.05 amps. It should be just fine. All right. So let me assemble the laptop and make sure that everything does work. All right, guys, thanks so much for watching. Please leave a like, subscribe, and you guys take care and have a good day. Thanks. Bye. Alrighty, so let's plug in there is a crack right here, by the way. That was there before we got the laptop, hopefully. All right, let's plug in the here. Let's see. All right, so we got the orange light right there. I want to wiggle it around. Okay. Let's switch the camera. Let's power it up. And we got cap lock on, escape, and we got Lenovo. We got Lenovo on the screen right there. All right. And we got an icon indicating that the battery is charging right there. Okay. And so here it's shown right there. You see, everything works. All right. And it says right here E595 Lenovo ThinkPad. Let's say ThinkPad. Anyways, so all the information is on USBCrepair.com. It's separate from this, from the power jack repair. Even though the company is the same, the prices and conditions are different on USBCrepair.com because, again, that's just time-consuming process to get the stuff done properly. All right, let's see. Keyboard works, touchpad works, Wi-Fi works, and the sound did work because it had the beeps. Well, hopefully the sound works. All right, looks good to me. Thanks so much for watching. Please leave a like, subscribe, and you guys take care and have a good day. Thanks.